Hello everybody, welcome to bowtieteacher.com. In this video we're going to be looking at the January 2019 paper from Edexcel for Maths IGCSE Paper 2HR. Now, as I was recording this video, I made a few mistakes, so I've gone back in and redone the whole video, not realizing I had my gaming headphones on. So hopefully that doesn't distract you too much from what I was doing, but yeah, I look like a complete idiot wearing my headphones. So hopefully that won't distract you too much from the maths that you're going to do and that you find this video useful still. So sorry about the massive headphones, but yeah, hope you enjoy the video, and if you need any help, please go to my website bowtieteacher.com and contact us, or you can leave a comment below and I'll try my best to get back to you. Okay, good luck, and I hope you do well in your exams. Okay, so for question 1, we have a frequency table with grouped data, which means that we have to take the midpoint and then multiply that by the frequency in order to work out the mean. First of all, we're going to look at the modal class. That's simply the one that has the most in the frequency column, and we go across, and it's always the one in the first column. So 12 less than D less than or equal to 16 is the answer for A, and an estimate for the number of days, the average, the mean, we have to take the midpoint. So 2, 6, 10, 14, and 18. And then we multiply that by the frequency. So we're going to do 2 times 16, 6 times 18, 10 times 19, 14 times 27, and 18 times 20. Once we've done all of those 5 calculations, we're going to add those up, and we get 1068, and we divide by the total frequency. So the total frequency, it tells us in the question, is 100. So we're going to do 1068 divided by 100, and that gives us our mean number of days of 10.68. For question 2, we have 2 blocks, and we have to work out the difference between them in terms of their volume. So we're going to work out the volume of brick A, which is going to be a half the cross-sectional area. So we're going to work out the face here, which is triangle, so half 6 times 6. And then we multiply that by how far it goes back. So times 5 to give us 90 centimeters cubed. For this half cylinder, we're going to do pi r squared, but the 6 centimeters is actually the diameter, so we've got to be careful of that. We're going to do pi r squared, pi times 3 squared, not 6. And we're going to multiply that by how far it goes back. That would give us the volume of the whole cylinder. So we'll divide by 2 to give us the half. So this is 3 squared times 5 is 45 pi over 2. And 45 pi over 2 is about 70. So we're going to subtract B from A. So volume of A minus volume of B. And that gives us 19.3 centimeters cubed. Okay, so cross-sectional area, in this case we did a half circle and then multiplied by how far you go back. Question 3, we have a sequence here which is going up by 6 each time, so we're going to go 6n, and if we write our n row here, 2, 3, 4, and 6n is 6, 12, 18, 24, we just have to work out how much we go up by to go from 12 to 16 or 18 to 22, so that's plus 4. For part B, we need to find a number that's in both sequences of 6n plus 4 and n squared minus 3, so we can just equate these two. Okay, so that will give us one answer in which will be in both sequences. So n squared minus 3, we're going to rearrange this to get a quadratic like that, which factorizes to give us n minus 7, n plus 1. Now, we can't have a negative n, so we're going to choose n equals 7. And when we put that into both equations, so 6 times 7 plus 4, or 7 squared minus 3, we get the same answer of 46. So we can just check that on here. This one goes up 40, 46, and n squared minus 3, we could do 6 squared minus 3, and then 7 squared minus 3, but 7 squared 49 minus 3 is indeed 46. So we know that that's in both sequences. Question 4. Jacob walked 10,800 steps. On Sunday he walked 7% more. We can just do 10,800 times 1.07. Let's just change that colour there. 1.07, because that's the 100% plus the extra 7. And we can work that out as, I think that was 11,556 maybe. But you can check that on your calculators. Question 5 is a bearings question. So we need to do the post box on a bearing of 220 from the library. So we start from the library, extend this line down, and then add, that's 180 degrees, and we need 220, so we need an extra 40 degrees. So you can measure that with your protractor and draw a line coming down. But we need 140 meters, where 20 meters is 1 centimeter. So 140 divided by 20 is 7. So we'll make sure that this line is exactly 7 centimeters long, and that will be the post box. Use your scale drawing to find the real distance of the hole from the post box. So again, with our ruler, we would measure the distance between the hole and the post box. And then the bearing of the hole, we would have to add our north line going directly upwards. And we could just measure this angle in here and take that away from 360, because we have to go clockwise for bearings. Okay, so measure that angle there and take it away from 360. Question 6, we have an octagon and a pentagon inside, but the pentagon is not regular. So we have to bear that in mind when we're doing our calculations. If we recall, the interior angle sum for a pentagon is 5 minus 2, number of sides minus 2 times 180, which equals 540 degrees. And we have a line of symmetry going down the middle. All that does is tell us that these two angles here, A and B, are going to be the same. So we can subtract 112, 112 and 84 from 540 and divide that by 2. So 112, 224 plus 84 is 308. So that leaves us with 232 degrees shared equally between A and B. So 232 over 2 is 116 degrees. So here we have 116. We now need to use the exterior angle formula, okay, which will allow us to work out this angle in here. So regular octagon, so 360 divided by number of sides, 8 in this case, gives us 45 degrees. So we've got 45 there, 116, and x. X plus 45 plus 116 equals 180. So x is equal to 180 minus those two put together. So we've got 161, so that leaves 19 degrees for x. Question 7 has a trapezium and we're tasked with finding the length y. So whenever you see these complicated shapes, we can break them down into triangles and rectangles, and that will allow us to use trigonometry to work out this length here. So we have 90 from 125. Let's just draw this triangle again here. We've got an angle in there of 125 minus 90, which is 35 degrees. We have a side length of 15 and the opposite of the angle is what we want to find out. So we're going to use tan 35 equals opposite over adjacent. So that opposite equals 15 tan 35. Okay. Once we've worked that out, we can add it to 37, and that will give us our y. So it's 37 plus 15 tan 35, and make sure you put your answer to 1 decimal place. Question 8, we're simplifying. So we're going to cancel the 15 and the 5, and that gives us our 3. K to the power of 4 divided by k is just simply k cubed, and m cubed divided by m squared is just going to be m. So we're going to have 3k cubed m. For part B, we have these double inequalities, and we can just treat them as separate inequalities and solve them in a normal way. So I'm going to add 1 to both sides to get 8 is less than 4x, less than or equal to 18. So I've added 1 to everything here. And then I can divide by 4. So I get 2 less than x less than or equal to 4.5. Okay. Question 9, we've got compound interest, so we're going to use the formula 6,000 times 1 plus the percentage over 100, and we raise that to the power of n, which is the number of years. So let's just change that to a 4. So 6,000 times 1 plus 1.5 divided by 100 to the power of 4. And this question is a bit tricky because it only wants to know what the interest is. So we're going to subtract the original investment. And that gives us 368 dirhams, I think. Question 10 is again some simplification. We can separate out all of these terms within the brackets and raise them all to a power of a half. So I'm just writing these out separately. 16 to the power of a half is the square root of 16, which is 4. And when we have the powers raised to powers, we multiply the two numbers together. So 8 times a half and 6 times a half gives you 4x to the power of 4y cubed. We're going to do some algebraic fractions. So remember, we can cross multiply these. So I'm going to take the 2 and multiply this. I'm going to take the 3 and multiply by that. And then I can times the 3 and the 2 to clear these denominators. So we have 2 brackets 8 minus 2x minus 3 brackets 2x minus 3 equals 4 times 3 times 2 is 24. Clear this up a bit. Be careful of the negative 3 and the negative 3 there. That catches people out sometimes. And then we get 25 minus 10x equals 24. X will be equal to 1/10. Okay. You can check that on your calculator by substituting a tenth back into there. Making f the subject, we have a square root to deal with first, so we're going to do m squared equals a third EF is EF divided by 3. So I can times both sides and then divide by E. Like that. Question 11, we have two straight lines and we're asked if they are perpendicular to each other, so we would multiply the two gradients m1 and m2, the two gradients, and if they're perpendicular they will give you -1. Okay, we should just round off the answer at the end to say whether Michael's correct or not. So the gradient of line L1, we'll rearrange this to get it in the form y equals mx plus c. So y equals -1/2x plus 2. So we can now see the gradient is -1/2. And for L2, we're going to use the formula m equals y2 minus y1 divided by x2 minus x1. So we have 9 minus negative 7 divided by 7 minus negative 1, and that gives us 2. So we can see that when we multiply these two together, 2 times minus a half does indeed give you negative 1. In question 12, we have some data that we have to find the interquartile range. So we're going to rearrange these in numerical order, and then we can start to find the median, the upper quartile, and the lower quartile. So we've got to just be a bit systematic with these, making sure that we're not missing any out. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11. Right, okay. So the median, we take the number of data sets here, the number of pieces of data, if you like, add 1 and divide by 2. That gives us 11 plus 1 over 2 is 6. So the 6th value is the median. Underneath the median, we have 5 cricket scores here. So the median of those would be 6. So that is our lower quartile. And the middle value of these remaining 5 will be the upper quartile. So we have 51 take away 6 is 45 is the interquartile range there. Three people sharing some money between themselves. That's a ratio question, but it's a bit more complicated because we don't know how much each person's getting or have anything like that. So we're going to use X as our unknown. For Carlos, Flavia got 65% of Carlos's money, and Tazia got 22% more, so 1.22x. Add those together, and that will give us £861. So we can rearrange this 861 divided by 12.87, and that is 300. So Carlos gets 300, and you could work out the other two if needed, but you don't need to in this case. Okay, question 14 is a tricky one. We have to try to express 3 to the 2x in terms of a or b. So we're trying to see if there's any link between 3 to the 2x and 3 to the x. So 3 to the x squared, like that, would give you 3 to the 2x, or 3 to the x times 3 to the x, because you would add those two powers to get 3 to the 2x. And 3 to the x tells us here is a. So a times a, or a squared. 3 to the x plus 4y as a power is going to be multiplied by 3 to the 4y, because you add those two together. So we're doing a reverse process. 3 to the 4y is 3 to the y to the power of 4, and 3 to the y is b. So we're going to have 3 to the x, which is a, b to the power of 4. For part 3, 3 to the y minus 1 is 3 to the y divided by 3 to the power of 1. So they would subtract those powers there. 3 to the y is b divided by 3. For part b, we have a times b is 2187, and a squared b is that number there. So we can actually say, well, a times a b from this one here equals 177147. We have told what AB is. It's 2187. So we can divide 177147 by AB, 2187. And we will get 81. So A is 81. B, we need to work out what A times B is 2187. So 2187 divided by A, I'm just rearranging this to find B, gives you 27. So B equals 27, A equals 81. And we can use the original A equals 3 to the x. So 3 to the x is 81, and 3 to the y is 27. So you have to think, well, what power could we use here to get 81? And the answer is 3 to the power of 4. So x is 4, and 3 cubed is 27, so y is 3. Barney has a biased coin. When the coin is thrown once, the probability that it would land heads is 0.3. Work out the probability that the coin will land heads exactly 3 times from 4 throws. So we could have heads, 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 tails, which would be 0.3 cubed times 0.7. But there's 4 different ways of having one tails. The tails could go first, second, third, or fourth. So we're going to multiply this by 4. And that will give us the answer for the probability that will land exactly 3 times. The probability that the coin will land heads at least once is a bit more difficult because there's so many possible ways of doing it. So when you start thinking, well, you can have 1 heads or 2 heads or 3 or 4 and all the possible ways of doing that, perhaps it would be easier to do 1 minus the probability of that not happening. So the opposite of having heads at least once is that you don't have heads at all. So the probability that you get 4 tails is 0.7 to the power of 4. And we can do 1 minus that to find the probability that there will be at least 1 head. Okay, so 1 minus 0.7 to the power of 4. Okay, for question 16, we need to have a look at the intersection of 3 different Venn diagrams and try to figure out logically what the numbers are going to be in each of the intersections. So if we start at the end bit of information, we have 2 people went swimming, played basketball and used the gym. So they're going to go directly in the middle there. The next one up is 7 people went swimming and used the gym. So swimming and gym is the intersection of those 2 circles. So we need that to total 7, and we have 2 already, so we need an extra 5. For the next one up, we have 5 people played basketball and used the gym. So basketball and gym is that intersection there, so we need that to equal 5, so we need another 3. And then for swimming and basketball, we have swimming here and basketball. So that has to equal 3, so we need an additional 1. We can then start looking at the top pieces of information there. So 28 people went swimming, so we need 20 to make that equal 28. For the basketball, we need that to equal 16, and we've already got 6 inside the circle, so we need another 10. And for the gym, 27, we've got 10 there, so we need another 17. We also have to be careful of the 120 total that were asked, because there's going to be some people that don't do swimming, basketball or gym. So we total everything up inside these circles, 20, 30, 40, 58, that leaves 62 that's going to go outside the circles, but inside the square for the universal set there. Okay, so the same way for every Venn diagram, you just start from the bottom and work your way up, and you should be able to fill that in nice. For part B, one of the people who went swimming is chosen at random. So we have the 28 people who were swimmers. If we go back up and we look in the circles there, we've got 28 people who were swimmers. Find the probability that this person also played basketball. Well, the basketballers are in that intersection of swimming and basketball, so that's 3 people. So the fraction of people that do both is 3 out of 28 swimmers. Question 17 is a bounds question, so we need to work out what E is to 2 significant figures. It could be 4.75, and it could go up to 4.85. For F, we could have 0.255, and that could go up to 0.265. So we want the lower bound for the value of P, which is E times F. In that case, we want the smallest E multiplied by the smallest F. So 4.75 times 0.255. For q, we need t divided by w, and we want the upper bound for the value of q. So the upper bound is going to be the maximum t divided by the minimum value w. So we're going to have 2.735 as a max and 0.035 for the minimum for w. We'd round that answer off to two significant figures. Question 18 is a sine curve, and we're actually translating this graph if we have f of x equals sine x, then sine of x plus 90 is equal to f of x plus 90. So you should be aware that when we have an f of x plus 90, so a plus or minus in the side the brackets, this is going to be a translation along the x-axis. If you have a plus, it's to the left, and if you have a minus, it's to the right. So x plus 90, we're going to shift everything to the left. So we're going to have this 90, 1 will become 0, 1 because we've moved it 90 to the left. And we're going to do the same for each of the points here. The last one, 360, this graph repeats itself like that. So we're just going to repeat ourselves there. And sketch in the curve. Try and make that look similar to the original. Okay, we're restricted to 0 and 360, so that's why I've made sure we only go from 0 to 360. So we don't need this extra bit here like that. We have to make sure that we have that part of the curve as well to take us all the way to 360. For part B, we have y equals sine x over 2 plus 3. Now in that case, we have f of half x, and then we have a plus 3 outside the bracket. So we have two transformations of this graph here. We're going to do f of half x, which is a stretch in the x direction, and we're going to have plus 3, which is a translation of plus 3 in the y direction. So our maximum point, if we just have a look here in pink, this is the maximum point of the graph here. This is going to be stretched in the x direction away from the y-axis. So twice as far away from the y-axis would take us to 180, 1, and 3 upwards, which is the plus 3 shift, would take us up to 180, 4. Okay, so translation of graphs, tricky one. We've got a combination of two there, half x and plus 3. Question 19 is an area of a complex shape. So we split into triangles and try to work out each individual section. So what we have here is two triangles ABD, and we can't work out the area just yet because we need to find this angle here. We also need to have another length because we need two lengths and the angle in between them to use the half AB sine C, the half AB sine C formula there for the area. Okay, so in order to do that we need two lengths and the angle in between them. So we're going to work out BD, and that will also help us to work out the area of the triangle BCD in a sec. So we're going to call BD, we're going to call that A, because it's opposite angle A. So A over sine 97 is equal to B, which is opposite B, 9.3, over sine 58. We can rearrange this to get 9.3 sine 97 over sine 58, and that will give us that length BD. So now we can use this to work out the area of ABD. So ABD is half A times B times sine of the angle in between them. So we need to work out theta, which is 180 minus 97 minus 58 is sine 25. So that's 25 in there because they add up to 180. So we've worked out ABD. We now need to work out BCD. So BCD is half A, we've worked that out here, times the other length, 11.2, multiplied by the sine of the angle in between them. So there's the A and B. Doesn't matter which way around they are, sine of 47. So we can add the two triangles together, and that will give us the shape ABCD's full area. And the x squared, so we're going to factor that out first, like that. And then we can complete the square on the thing inside the bracket. So I'm just going to do that in a different color. So x squared minus 4x, sorry, x minus 2 all squared. Then we minus this thing squared plus the 7 over 3. So we've got x minus 2 squared minus 4 plus 7/3 is minus 5 over 3. And we've still got the 3 in front. So we can distribute the 3 and multiply everything inside by the 3 to get 3x minus 2 all squared minus 5. Okay, so completing the square is useful for us because we can use it to sketch a curve. And we can find the vertex, that point there, the minimum point of the graph, is given by this and this. So for the x minus 2, we reverse that to plus 2, so that will give us 2 for the x coordinate of the vertex, and the negative 5 is the y coordinate. So that is the exact middle of the graph here. And so a line of symmetry would have to pass through that point there. It's a vertical line, so the equation of that for part B is going to be x equals 2. Question 21 is very tricky to spot what this is actually about because you're doing an intersection of a curve and a straight line. So whenever you want to find the intersection points of two equations, you do simultaneous. So y equals 10x squared plus 10x minus 3x is plus 7x minus 3 is our first equation, and our second equation is y equals 6x. So I've just rearranged that linear one there. We can now substitute the 6x into the first equation, rearrange, minus 3 equals 0, and we can factor this. So 5x plus 3, 2x minus 1. So our x equals a half from the second bracket, and x equals negative 3/5 for the first bracket. The y values, we're going to do y equals 6x, so y equals 6 times a half is 3, and y equals 6 times that is minus 18/5. And we've now found where these two curves, this curve and this line intersect. So there and there, and it wants to find the coordinates of the midpoint of A and B. So we'll call that one, this is A down here, and this is B up here. To find the midpoint of 2 points, we just take the average of the two. So we'd take the average of a half plus negative 3/5 over 2. That will give us the two x values averaged, and 3 minus 18/5. So I was doing the 3 plus negative 18/5 over 2. And a half minus 3/5 is minus 0.1 over 2 is minus 0.05. And 3 plus, that's minus 3/5 over 2 is minus 3/10 minus 0.3. So that is the midpoint of A and B there. So simultaneous equations plus midpoint together, that's a tricky question there. Hope you followed that one along. Question 22 is also very tricky, lots of this one. We've got a sector of a circle, and the distances between these are in a ratio. So if we say that from 0 to P is R, if we call 0 to P r, then OA is 3/5 of r, and A to P is 2/5 r. And that's the same on this side as well. So we need to work out the area of the shaded region would be the larger sector, subtract the smaller sector. So the larger sector is going to be pi r, because that's the whole length there, pi r squared times theta over 360. That's the formula for the area of a sector. So theta is 45 here, so we're going to have 45 over 360 is an eighth. So pi r squared over 8 is the area of the large sector OPQ. For the smaller sector, we've got pi times the radius, but in this case it's 3/5 of r squared times 45 over 360 again. So this is going to be 3/5 squared is 9 pi r squared over 25 times an eighth is 9 pi r squared over 200. So we have the two areas here. If we subtract them, that will give us the area of the shaded region. So 81 over 2 pi is equal to the larger one, pi r squared over 8, minus the smaller one, 9 pi r squared over 200. So times this one by 10, we get 810 over 200, 8100 over 200, and times that by 25, that gets that 200. So I'm just getting these common denominators here, and then I can cancel these all out. So we have 8100 pi equals 25 pi r squared, pi r squared minus 9 pi r squared. So we can cancel the pi's on all of these, and we get 8100 over 25 minus 9 is 16 equals r squared. So r is the square root of 8100 over 16. 8100 over 16 square rooted is 45 over 2. So we know that 45 over 2 is the radius, and to work out the perimeter we need AP, QB, the arc PQ, and the arc AB. So let me just scroll down a bit here. So to work out the perimeter of this shape here, this shaded region, we need AP and BQ, which is 2/5 r. R is 45 over 2. And AP and BQ are the same length, so we're going to have two of those. So we're going to times that by 2. Plus, we have PQ, so the arc length is, the formula for that is 2 pi r times theta over 360. That will give us the larger arc, and then the smaller arc AB is 2 pi, we're not using r this time, we're using 3/5 r, 3/5 r times 45 over 360. So quite a complicated one there. Let's try and tidy this up. We can cancel some 2's, cancel that, and we have 18 plus 2 pi r times that is, divide this, 180, 45 over 180 is a quarter, so pi, and we've got still times by r, so pi times 45 over 2 times a quarter plus 2 pi times 3/5 times r times 45 over 360 is an eighth. So we'll try and cancel some of this down. We've got that to give you a 9. The 2 and the 2 cancel. So we have 18 plus 45 pi over 2, 8. 2 times 4 plus 27 pi over 8, which will give us 18 plus 72 over 8, that's 9 pi. Quite a lot to that one. You might find an easier way of doing that one, but that's a tricky question there. You need to know the arc length and the area of the sector formula for those. Final question, 23, is another series question. So we need to know the formula for the nth term is a plus n minus 1d, and the sum formula, which is given in the front of the book, 2a plus n minus 1d, like that. So for the 10th term is 66. So 66 equals a, which we don't know. N was 10, so 10 minus 1d. A plus 9d. And the sum of the first 20 terms is 1290. So 1290 is n over 2, 20 over 2, brackets, 2a plus n 20 minus 1, 19d. So 20 over 2 is 10, so I'm going to divide by 10, and I get 129 equals 2a plus 19d. So I've got some simultaneous equations here. I can double this one here, double this first equation to get 132 equals 2a plus 18d. And I can subtract those two equations from each other. So 132d equals negative 3. When I subtract 129 minus 132 is minus 3. 2a minus 2a and 19d minus 18d gives you d equals 3. A is going to be 66 minus 9 times minus 3. Okay, so I've rearranged this one here, and that will give us our A value. So 66 plus 27 is 93. A equals 93. So now we can finally find the fifth term. The fifth term, U5, is A plus n minus 1 times negative 3. 93 plus 4 times minus 3 minus 12 gives you 81. Okay, so a bit of a whistle-stop tour through that paper there, but I've tried to show you my sort of thought processes as I've gone through. I realized about halfway through the video that I had my headphones on, which is really embarrassing. Didn't mean to do that. So apologies for looking like a complete fool, but hopefully you can still concentrate on the maths behind this paper. And if you have any questions or comments, then please do get in touch. You can go to my website, bowtieteacher.com, and there's a contact there, or you can email me, or you can comment in the video and I will try and get back to you. Okay, good luck, and I wish you all the best in your exams.